Well, we're here at the 2017 ASABE quarter scale competition this year. We've got 25 teams from around the US, Canada, and Israel here this year. And it's the student design competition that's now been going on for 20 years. As far as teching, the engine station sets the engine or the high idle speed of the Briggs Stratton 31 horsepower engine. They also check to make sure that the exhaust shielding meets our safety rules based on ISO standards. So they will have the driver run the tractor up to high idle and sit there for 3 minutes while they check with a thermocouple on all the surfaces that could be hot to ensure that no surface that the operator could come in contact with exceeds 80 degrees Celsius. For the sound teching, all the teams must go through to demonstrate that they fall below the 94 decibel level. We have the teams drive a course 3 times going both directions, forward and back, so that if their exhaust is pointing out one side or the other, that it's adequately captured during that. And they'll make 3 passes, and then we average the scores based on the sound levels demonstrated during those 3 passes. The brake stand is always one of the most challenging parts of the technical inspection process. What on the surface looks to be a very easy test to pass is actually one that is commonly missed by a lot of teams due to their brake designs, and they have to go back and make some modifications in order to pass it so that the tractor does not roll when the ramp gets to its highest point. So on Friday every year we have the static design judging portion of the competition, which is where all of the students get 10 minutes with 5 different groups of judges so that their tractor can be evaluated on ergonomics, manufacturability, safety, serviceability, and testing and development. During that time, 5 to 6 judges from industry will walk around the tractor with 3 students and evaluate the tractor based on that certain category, and then score it for the competition and also give feedback that we will provide to the teams so that they have a chance to improve for next year. It's a valuable part of the competition, as a lot of the criteria that industry uses to evaluate a design is evaluated in that situation, and real industry professionals are giving their opinions to the students, which help them develop the tractor even more. So the X-Team competition has 2 main benefits. First of all, it's an opportunity for younger students at a school to get involved with the quarter scale process and the quarter scale competition without needing to do a full design and build cycle. In addition, it also simulates the continuous improvement side of industry that's also very important. Since the teams take an old tractor, make a few changes to either fix a problem that it had or to improve it and make it better, it simulates the CI process that many of us in industry work on every day.
On Friday night of competition, we have the GSI sponsored pork fry, which gives students the opportunity to interact with sponsors of the competition itself and fill their bellies after a hard day of tech inspections and working on the tractors in order to meet specifications. During the oral presentation, teams simulate a product readiness review by presenting to a board of engineering management and product development personnel the design concept they selected, the general target market and the cost strategy, as well as the design analysis and product verification they conducted in order to ensure that their product is ready for production. This simulates a real-life experience for a new product program and the development of a new product for market for implementation. The maneuvering course simulates another portion of the well-rounded experience that we try to provide the teams during the performance part of the competition. The maneuvering course itself simulates tight turning and compact maneuvers that the tractors must execute in application. The course is constructed of yellow and red pylons to simulate a tight turning area that will force a tractor to turn left and right, back and forth, and contact red pylons in very tight quarters to demonstrate the maneuverability of the tractor. This course is set up very tight and challenging for the teams in order to separate the men from the boys when it comes to maneuverable design of the tractor. The durability course consists of an oval track consisting of bumps on one side and a sand pit on the other side, and essentially operates as a speed-limited race amongst the teams. The teams have to complete 10 laps in a 12-minute period on the track in order to complete the course and get a time score. The bump track portion of the course simulates a shake test, very common in industry, which helps validate the structure and reliability of chassis components on the machine, especially front axles and the main frame of the machine. The sand pit simulates an area of inclement traction as well as trying to float over an area and pull that towed load, and demonstrates the tractor's ground clearance, tire ground contact pressure, and the ability to generate traction on poor surfaces. The durability course is probably the most strenuous part of the performance competition, and we see many tractors face significant challenge completing the course without failure or without driving off course. The bump track typically induces stress on the steering components, and we'll see failures on that come out throughout as the tractors run the course. The sand pit oftentimes will cause teams to bog down and get stuck, and or lose traction throughout the course and end up losing time, preventing them from completing the course.
So since this year was the 20th anniversary of the competition, we had an alumni event to bring back former competitors with their tractors to pull. This year we had tractors from the original 1998 competition and all of the design iterations based on the rules changes that have happened over those 20 years. We had, from the original tractors, we had many of the four-wheel drive tractors from the early 2000s. We had representation of the multi-engine tractors from the late 2000s, plus some of the 31 horsepower tractors that have been built here within the past few years. In addition, it showcased that some of our alumni have also gone on to do recreational polling on the quarter scale circuit.
On Sunday, the last day of competition, teams get to wrap up probably the most fun part of the performance competition, the tractor pull. This comes after the performance events from the previous day, which oftentimes led to failures of the students' tractors, so getting things back and ready and rolling for the pulls is sometimes a bit of a strain on the students. Oftentimes the welders roll all night and the trailers stay open for teams to get fixed throughout the night and prep for the pulls. The tractor pull competition consists of 3 pulls splitting between a 1,000 and a 1,500 pound weight class, which demonstrates a team's ability to get power to the ground with their tractor design through both tractive efficiency and delivering the engine power to through the powertrain to the wheels. Teams must correctly assign ballast and tire pressure and tread setups to their given weight class in order to maximize the pulling performance of their machine and the pulling distance down the track, which ultimately sets their score.
All right, Montana 6 rolling out to 45 feet, 4 miles an hour. Past the point over turn, 75 feet. Still maintaining about 2.5 miles an hour through 100 feet. Taking it straight down the middle of the track through 150. Starting to get just a little bit of there, through 130. Not a little more like now.